This is the fourth lecture in permutation and combination series. And let's see what type of questions we have. So in these kind of questions, there is some kind of condition, some kind of restriction that, let's say, the vowels always come together. So in this particular lecture, in fourth lecture, we'll only consider vowels that come together in a word. If you remember back to first two lectures, we were discussing permutations. So this is also permutations in which the order matters. We consider the order in which the words are arranged. So we count them. But the thing is, there is a restriction now. So the vowels always come together. There was no such kind of restriction or condition in the first two lectures. There we only considered the total number of arrangements, or maybe if a letter is repeated, but it didn't say back in those lectures that we will be restricting those letters in the same place. Maybe they come together, or maybe at the end, or in the first place, or maybe at the back of the word. But in this case, there is this restriction. So how we can easily do this, or we can intuitively think about this, is that you can first combine the vowels. So in this case, there is one more vowel, A, I, O, U. There are four vowels in this word, auction. So I've written them together, and I'll write the remaining letters, C, T, N, S, the consonants, differently. So they'll be treated as another block. But don't confuse these two blocks as separate. You might think that the consonants will be separate, and I'll need to count them separately and need to count this separately. The only restriction is that vowels come together, but in the same time, the whole word is combined. So while you write your vowels together, this will also be considered. Now let's break this down. So it says, again, vowels come together. So you can first write one pattern. So let's say I wrote the consonants in this particular order, C, T, N, S, and then I write the vowels, A, I, O, U. Now you know that for this particular pattern, C, T, N, S, the vowels will change because it says the vowels always come together. So only for this particular pattern, there are four vowels. They will keep changing. So what is 4 factorial if we remember back to our basics? So this is 4 factorial, the vowel block, which is 24 different ways that you can arrange these 4 vowels. So it means that for this particular pattern, CTNS, there are 24 different ways I can arrange these vowels. And you can imagine that if I change this pattern, the CTNS pattern, maybe I move the T and swap the T and C, that is only one pattern. For that pattern, let's write that down as well. So I can write that over here. So now we swapped T and C. That is the only change I made. But now this is a totally different pattern, T, C, and S. Now you can imagine this, that there are another 24 different ways that the vowels can be arranged for this consonant pattern. So now you can see that there are 24 different ways for each of one of these patterns. Now let's write this in the equation form. I will erase everything again and restart. So let's write the vowels. And here are the consonants. Now I told you that let's first just count this. This is 4 factorial, 24 different ways the vowels can be arranged. But you also have this, CTNS. So this whole thing will be treated as one block plus 4 of these letters. I'll write it down here. So this is 5 factorial, basically, because the vowel block is treated again as one block. So, and there are 4 letters of consonants which are totally different, CTNS. So there will be, the entirety of this will be treated as 5 factorial, which is 120. And then I need to multiply this with the 4 factorial for the vowel block, which we considered that for each of this pattern, whenever this is held constant, there are 24 different ways we can arrange the vowels. So now you have understood it intuitively. So let's just multiply it. This becomes 5 factorial times 4 factorial, which is 120 times 24. And you can do this kind of calculation very easily. This is just 2880. So D is your answer. let's move on to the next question. The idea remains the same, the concept remains the same. So here the word is optical. So I'll again, the vowels come together. I'll arrange the vowels in one, treat them as one block. So I'll write the vowels first. So the vowels are O, I, and A. And then you have your consonant block, which is P, E, C, L. So again, for each of this pattern, like we just did in the first question, the vowels will change their places. So this is what, 3 factorial, 6. Meaning there are six different patterns or 6 different arrangements that come for each of this pattern, one of each of these. And then if you swap the letters or change around the letters of the consonant, there will be 6 more different arrangements for each one of them. So again, we need to do the same thing. We need to count this as one block and these 4 as a individual block. So this again becomes what, 5 factorial? And then you need to multiply this with the vowel block. So it's the same calculation. So 5 factorial times 3 factorial is just 120 times 6. This becomes 720. So this question was a little bit easier because there are lesser vowels and lesser words. So that's your second question. So now let's see what the last question will be. There are only 3 questions. So this is a little bit longer word, corporation, and you can see there is a lot of repetition in this. So it will be interesting to solve this kind of question. So if you can solve this kind of question easily and think about it, then this is the most advanced question. Then you have the topics nailed down. So corporation. Now you can see that in corporation there is repetition in vowels as well as the consonants. So it is, as you can see, these questions are already nested. There are 2 layers. Now there are 4 layers instead of 2. So this is a little bit more involved. So let me write down the vowels first. So there is I and A, which are non-repeating, and you can see O is repeated 3 times. So just for the sake of simplicity, I'll write down O 3 times. And then coming to the consonants, which is you have C, P, and R is repeated 2 times. So I'll just write it down 2 times. This is to help you understand it in a better way. And then you have TN. So I've got all the letters down and I've written the repeated letters in yellow ink. So the thing about this is that what you can do to make it easy is that you can count all of them with repetition. And I'll explain it why later, but let's first just consider them in repetition. So you have 3 vowels, but since O is repeating 3 times, you'll write it down as 5 factorial. So this is 5 factorial for the vowels because there will be 5 letters and we have treated the repeating letters as different as well. So this in itself is 120, meaning the vowels are repeating. There are 5 vowels if we count O 3 times instead of 1. So the vowel block is 120, meaning again, if I talk about the concept that for each time I hold the non-vowel letters, the consonant letters constant, there are 120 ways the vowels can be arranged. And then coming back to the older concept, this is not really 120. Remember, if back to the first or second lecture that where we didn't have this kind of condition, but we used to say there are letters repeating. What we used to do is that let's write a word like that. So remember we did this word create. Now we used to say that although E are the vowels and they're repeating, although they are different, but they're in the viewer's mind, in the observer's mind, it's the same thing. Both of the E's, whether they are arranged together or in any kind of pattern, they are similar, they are identical. You cannot differentiate between E's. So we used to consider all the letters. So there are 6 letters, so 6 factorial divided by 2 factorial, because E is repeating 2 times. So this used to come around about, meaning there are 360 different ways of arranging create. It was cut in half. So if you just consider that all of the letters are different, then it's 720, because E is repeating 2 times, all the patterns or arrangements, the count of them is cut in half, because E, no matter how you arrange them, it's the same thing. Whether you swap them, it's the same thing. So coming back to this question, let me erase this. So we are doing the same thing with this. There is nothing different like we did in that, back to the first lecture. So same thing will be applied here. So 5 factorial divided by, since there are 3 O's, divided by 3 factorial. So this will be 6. So this comes around to 20. And similar thing you will do with R as well. So since there are C, P, R, R, T, N, now let me first do it in the way that we have been recently doing, is that since there are 6 of them and we treat the vowel block separately or as one block, this will come out to be in entirety 7 factorial, because there are 6 of these letters and one vowel block. So this whole thing becomes 7 factorial. And since consonants are treated differently, we can just divide this whole thing by 2, because there are 2 R's. R is repeated 2 times. So this calculation becomes 5040, which is 7 factorial, divided by 2. This becomes 2520. So 2520 are the total number of arrangements that you get when you consider this as a whole, vowel block as a whole. But then you also know that we need to multiply this number with 20, because vowels also have to be considered when writing the whole thing. But since they come together and O is repeated 3 times, the number is only about 20. So then your final calculation becomes 2520 times 20. And you can see this is around 50,000. So this D will be your answer. So since I remember I have been putting in your brains that thing about permutations and combinations is that factorial grows very fast, very exponentially. So you will be dealing with very large numbers. So always remember to estimate, don't try to calculate the exact answer. So since 2500 times 2 is 5000 or 20 is 50,000, get somewhere around 50,000. So D would be your answer. So this is how you treat a really large word with so many repetitions. You break it down, you consider the vowels first and then the consonants differently, and then you treat repetitions separately. So then your calculations become very non-confusing and very, very clear. So now we'll see in the next lectures what kind of pattern we get. That's it for fourth lecture.